You should be ready to go.
Hey there. You all hear me? See me?
Looks fine
Things
on my
looking
end.
good? Looks good? Hell yeah. Awesome. Okay, so I'm gonna start this up. Hi everybody. My name is netspooky. I am a reverse engineer. I work and specialize in embedded devices, industrial control systems, and some esoteric kind of firmwares here. And so I wanted to do a talk. My first talk will be about firmware analysis and the introduction to it. So it's tough because I talk to a lot of people about firmware analysis and about embedded devices and hardware hacking and firmware always really seems like very like scary because it's a lot of it's very low level, a lot of it's assembly, custom architectures. There's all sorts of weird things. It's a bit of a different ball game from say doing analysis of regular software or doing penetration testing or different vulnerability analysis for web apps because those tools you see things that are a lot more apparent. The output of an XSS is a lot more apparent than say overflowing a buffer on some emulated firmware. And so I kind of wanted to just go through and give a very high level overview of firmware analysis and show a few examples. So I made a page here. If you go to my website, it's here, I'm going to give this to Corinne so that they can put this in the chat, or I'll throw this in the Slack chat too. I'm not sure where the chatting is actually happening, but here we go. So this is my what's it called? My website. So this page here is under construction. I've been doing a bunch of streaming, so I didn't have too much of a time to put together a full guide, but I wanted to give some jump off points and then be updating this in the future, so that if we have a if I ever do like a talk about this, be able to have this as some sort of a guideline. So with firmware, firmware comes in a lot of shapes and sizes. It comes for a lot of devices. I mean, a lot of things run firmware. Everything from your phone to your fridge, your smart fridge, to your some embedded devices that you might have around the house, your router, anything that pretty much has some sort of way to be controlled digitally will likely have some sort of firmware. And so whether or not it can be updated or extracted, or the ease of that is a different story. But we're going to go into basically for the high level for somebody who's never done firmware analysis before. Here's some sort of guidelines that I typically, things that I typically ask myself and what I'm looking for while I do this. So establishing goals is probably one of the most important things. So this whole section up here, establishing goals is really, really important for analysis, because doing analysis can be done for a multitude of different reasons. And so there are, you might want to modify the functionality of the firmware to, like, say, make it do something different, maybe add some functionality or remove some, if there's some spying capability or something that you're worried about. If you're looking for vulnerabilities, is another big thing. If you're looking to exploit the device, you will definitely want to look at the firmware and see how it actually works. You might be looking for sensitive info. So you might be doing like even like a bug bounty and looking for like sensitive endpoints or auth mechanisms or private keys or passwords that might be reused across devices. You might also be looking at protocols. So some embedded devices are going to be talking some really obscure internet protocols, serial protocols, or they might be having their own proprietary protocol, and you want to understand exactly how that is processed by the operating system or the firmware device. And sometimes you just want to understand how it works. I mean, that's really how I got into all this. I wanted to see, how does this actually work? What do I do, like, to actually peer into it? And it's great for curiosity. I got started by doing this stuff in my free time for fun. Now I get to do it professionally, and it's amazing. And so, yeah, so that's basically the important aspect, is just establishing some goals for yourself. So when you go into this, you don't get overwhelmed by the possibilities of things you can do, because it's pretty endless. So now there's basic questions that I like to ask myself and others when I'm working with them on a project like this, to analyze some firmware. So the big one is, what is the actual target device used for? Like, what is the use? Is it a router? Is it a camera? Is it a smartwatch? Is it a industrial control system? Or what does it actually do? Like, who uses it? Things like that. Those are like really important things to ask for yourself. What is the underlying processor architecture is also really, really important to establish early on too, if you are looking at things from any sort of analysis perspective, because that way you'll be able to know, what kind of tools you might need, whether or not you can emulate it, how easy it'll be to do so. What features does it support? So basically, like, what does it do? Like, what sort of, does it have like a web server on it? Does it have, SMB? Does it have a, remote procedure call? There's a ton of different features that it might actually have. It might have some things that are only available in like a debug mode. It might have stuff that only is available, when it starts up. What type of operating system runs on the device? And so that's the next big question here. Not every device has an OS. So it's common now for a lot of embedded devices to have an operating system like an embedded Linux or a Windows, but sometimes they might not support that. They might not have the ability to do that. So they might have an RTOS, which is a real-time operating system. And you can look those up if you are more interested in them. Those are things that are done for real-time applications, and certain devices will definitely use a real-time operating system over Linux because it's faster, and there's a lot of advantages to it, but there's also some disadvantages where it's not as easy to work with all the time. And sometimes there's just bare bones application code. So if you're looking at firmware for something that's really, really simple, it might be just raw application code. It could even be something like like Java bytecode on like a VM, or it could be like .NET Core embedded or something like that. There's so many different kinds that it could do, but some of those will run and be a bare binary that runs on the system, and that's all that runs. So it's really important to establish what the actual operating system or what the actual code that runs on the system, like how it actually processes data. So that's very important to establish. Other chips on board is really important if you're looking at it from a hardware perspective. It also gives you a view onto what the actual what's it called, functionality could be. There's a Wi-Fi chip. That's really important to the functionality. You might be like, okay, so that's Wi-Fi. I know it has an ESP 8266 on board or something, or a Bluetooth module. And then what types of programs run on it. So that's definitely really important to understand too, how a program is loaded, how is the functionality changed. So the next step to talk about is getting a hold of firmware. So firmware can be very difficult to track down sometimes. Sometimes you can get them on a vendor website. Other times you have to use a bit of OSINT. So you use Google dorking, searching a whole website for a file type, maybe bin or zip. Using Google dorking, definitely huge. Sometimes they might even have it on some like weird JSON endpoint that like has links to firmware that you can only get if you've been given like an auth token from the device, from the server. So another big one, the harder ones are analyzing firmware updater apps. So you might have an Android app that updates something. You might have a desktop like Windows app that loads firmware, might have the firmware packed into it. There's all sorts of things like that. You might have to look into that. Another big thing is PCAPs. So I've pulled like stuff directly out of PCAPs before, firmware. It's definitely challenging sometimes to make sure that everything is where it should be, but that is not out of the question. If you have a updater app and it's encrypted at rest, but it's decrypted while it goes over the network, using a PCAP or using a Wireshark or TCP dump, you can grab sometimes firmware straight from a PCAP. And sometimes you have to directly interface with the hardware, which I'm not going to get into here, but there's an awesome talk, Buses Can Fly, shout out, I know he's watching. He did an excellent talk on hardware hacking for the masses. It's a really cool talk about a lot of this kind of stuff too, and how to extract firmware from a hardware device. So the next big thing to look at is firmware files. So how is firmware updated? So there might be the firmware updater apps we talked about before. There might be a zip file that you have to upload. There might be some other mechanism. However it is, you want to know how it's updated, how it gets onto the device. What is the actual file format of the firmware? If you have a second later on, I will be able to show you some custom file formats that firmwares are in. Is the file encrypted? So the firmware might be encrypted and decrypted by a decryptor stub or a program that's on the device that actually takes the firmware, validates it, and then applies the firmware changes. And then is the firmware that you've downloaded a full image, or is it just some sort of patch? So one second. So that's really important to know too, is whether or not the firmware is, it might be a full firmware image that is a full operating system, a full RTOS, whatever you want, from the, that gets directly loaded onto disk. Sometimes they might only patch just a small portion of it and still have, other firmware, other things that actually run the code that you sent it. So imagine like basically sending it a new binary to run, a new exe or something. So the last things too are interaction. So as a user, how would you interact with the device? Do you have a web app? Do you have Android app? Do you have a front panel or a mixture of all those? How would you interact with the device as a developer? So there's like debug ports, things like that. If you wanted to program the device or reflash it, inputs and outputs the device might have in general, similar to the other interactions. And then how does the device interact with other hardware devices that are on the system or non-volatile memory? So these are all really important things to question too. And the last things here are, if you're looking for vulnerabilities, are there any known vulns for this device or any of the technologies on board? And are there any write-ups or blog posts about this device? You can definitely get caught up into a wormhole of looking up stuff without having looked at prior research, and it's definitely important to look that up. So, all right, we have 10 minutes left for this this section here, so I'm just going to go briefly over some techniques. On this page too, I have further resources which are awesome. Just some videos that I have here. I'm going to add some more as time goes on, but these are all some really cool mixture of beginner and advanced things you can do. So for me personally, everybody has their tools. Everybody has things they like. I am a huge stand for Radare 2 and the whole Radare suite. So I'm going to demonstrate using some of those tools a little bit. File carving is really, really important too if you're looking at firmware to extract files. So binwalk and all the file system unpackers are really, really important. If you want to get into it, emulation is really cool too. You can use QEMU, you can use Docker with QEMU and run, say a router in Docker. It's virtualized. It seems like it's running in native hardware. ARMX is another really cool router virtualization framework, and Firmware is used for Linux-based devices and emulating those. And so binary diffing is also really interesting if you're looking for vulnerabilities too, to see what changed. And then in this talk, we're going to use this firmware. So if you do want to play along at home, we're using this WNAP 320 firmware. Some other things I wanted to discuss too. Okay, I'm just going to jump right into this. Alrighty, so here's my, I had to put all this on here because I had to switch over to another computer real quickly. So this is on a my VPS. So hopefully everything works the way that I think it's going to. But we're going to start off with this here, this WNAP. So I'm just going to go over some real quick things. So this came directly from the vendor. So this is firmware version 2.0.3. This is for a router. So what we'll do is just extract this and see what it looks like. So this is like what you would send this to a router to update it. And so in here it gave us a tar file, and then it gave us release notes, which if you read the release notes, it just explains what was changed, how to load the firmware. So right now I'm going to make a file system directory, because what we're going to do here is we're going to tar this file, right? And it gives us, a squashfs, which is a file system that the whole firmware is running on. It gives us this VM Linux, which is like the kernel, and then we also have what's it called, some of the hashes to make sure that those are okay. So we're going to use unsquashfs real quick. Hold on. Yeah, I'm not going to be able to make any devices. So we just real quick, we just unpacked the file system on here. It's a Linux file system, so this one's a much easier thing to analyze. So if you're playing along later, it's definitely really cool to play around something that's a bit easier to look at. So we can like go to like etc, and we can see like init tab, which has like some of the initialization functionalities, which shows us like some of the things that it does. Is mounting disks, opening up serial port, things like that. You can ls or ll init-d, and you can see all these scripts that are used to start up the software on the system. There's also something that you'll notice a lot too. If you go to like say bin, pretty much everything in here is symlinked to BusyBox because a lot of embedded devices, especially or a lot of embedded Linux devices, are using BusyBox as their primary like interface for the shell. So if you run something on a shell with it'll go to BusyBox as like an argument to it, and then it'll run that as like an all-in-one sort of utility. It's very useful, but you'll see that a lot here.
I'm sorry to interrupt, but is it possible to get the font a little bit larger for everybody?
Sure. All right. Is that good? Should be good.
That's probably great. Thank you.
Okay, cool. All right. So also the other thing too. So when you're on here, we have full. Hold on. Oh Lord, hold on. All right. So if you're in Etsy too, we can look at stuff like shadow and like cat password. Like these are like device like system users that are on here. So it's like when you're looking at firmware, you can sometimes see things that you would normally be able to see interacting with the device. So here we know there's admin users, default non-root. There is a root user. Doesn't seem to be any passwords set on stuff. All interesting things. You can go to like the home directory. Oops, hold on, I'm like having an issue here. 1 second. So I made the font size bigger. It's kind of messing up things. So we'll go to FS. So home, we know that there's like a web server on here. So this is like where it's served out of. So basically poking around and exploring stuff is like really, really awesome. If we go back here, we can do things like search for begin RSA. So we do like a grep and find that, oh, there's a private key here. There's a private key in dropbear. So we can like cat those things and we can find some secret stuff. So there's some private keys here. I don't know what they're used for. We'd be able to look, and if we did more in-depth analysis. You can do really advanced things like finding all the IPs that are in here. So I have this long grep that I didn't put in my my thing here. Hold on 1 second. We have this long grep that was able to find all the IPs in here. So sometimes this is useful if it's going out somewhere else. It's not in binary mode, but we do know that like BusyBox, DHCP has all these things. Always really useful to enumerate this kind of stuff from a firmware. If you go to, are we in this? No. Like in here and user local bin, we see that there's a bunch of other things in here too for scripts. So yeah, basically the point of this is to just show that we're in here, we've unpacked the firmware, and we're now looking at it. If we wanted to, upload this back to, if we wanted to change something, upload it back, it would be pretty simple because this here just has some MD5s. So we'd have to just change what the MD5 is of the tar file, and then we'd just be able to upload it back to the router. I'm gonna only have a couple more minutes on this. I'm just gonna go real quick and show you some other firmware. So yeah, I'll go to mystery router. So I can't really talk about some of these routers because I've done some bug bounties with them. Here's one I'm calling mystery firmware.bin. And so this one here, if we run bin walk, right? We're able to see if there's a squashfs file system on here. So we don't know what this bin is, it could be anything. So we run this and we carve out this compressed data here, squashfs. And so we can go to that mystery firmware and then, oops. Yeah. Hold on 1 second. I might have messed this up. Yeah, well, regardless, I typed the wrong command. I don't think I have squashfs on this for whatever reason, but I'm able to extract it the same way that I did for the other firmware here. But so the reason I wanted to even show you this was because in here we see that there is a custom file header. So we did that bin walk, right? And we see that at offset 56, there is some compressed data, and at offset 3A, there is a firmware header, right? So 3A, firmware header. So we look at 3A, and that's right here. this is the start of a firmware header, and it ends at 56, which is like right here. And so the firmware header itself is this big. And so, you know, there might be data here. You look up in online what kind of firmware header that is. This will have metadata about it. It might be like the size of the firmware, the size of the sections, hashes, all sorts of things that are usually included in a firmware header. So very important to know that you might see something like that. You might have to modify it if you are changing it. So the last one I'll show you is from a mystery vape. So this one here, if we run binwalk on it, right, there is nothing that comes out of it. And so when you see something like this, and it's just blank, there's nothing in here, usually you're gonna have to do some digging by hand. So when I'm looking at something like this, something like a vape, it's gonna be very, very, like, it's gonna be a, what's it called, like more of a bare bones kind of thing. Like you wouldn't want a vape to run Linux, I don't think. But on here, you'll see something pretty common for a lot of these sort of things. So you'll see what looks to be like a bunch of zeros, like offset like this. And usually what this would mean for something like, say, ARM, would be, this would be like the first address that would be jumped to by the actual chip. So it would say, okay, I'm going to start at like 57480483, somewhere down here. It could be a virtual address and it'd be loaded somewhere high up into memory. But the rest of these are usually going to be addresses that are returned to, which are really, really important if you're reverse engineering, to understand where the interrupts are, how like the processor handles certain things. So it's that's a important tip to know. But yeah, when you look at something like this, you might see it laid out like this, and you definitely know that it's probably like a raw binary firmware image. There doesn't appear to be any strings in here. If I did like robin2 mystery.bin, it's going to give us a bunch of strings. I'm really a fan of robin2 for string searching. So -ZZZ or -Z, depending, will give you strings from here. There doesn't seem to be anything in this firmware, but if we, hold on, like let's say we went to firmware analysis, FS. So let's say we just did like robin2-ZZ IF rename or whatever. You see a bunch of stuff in here like error strings, things like that. But it also gives you the offset, which I really love. So very useful. You can also use robin2-I to look at things and give you the firmware architecture. So like right here we see MIPS is the actual processor architecture for that other router that we first looked at. It's an ELF, uses this linker. So yeah, that's pretty much it, I guess. I'm kind of done now with this side of the talk. Thanks, Karen, for reminding me here. But yeah, so this, I'm definitely going to upload a bunch of stuff to this page here, soon. So just keep an eye out on it. And also obviously follow me and at me or DM me if you have any questions about this part of the talk. So now I'm going to share and do some bookbinding. So here we go. All right, so this is a bit more relaxing and not as crazy overall. So yeah, Japanese bookbinding. Just gonna switch over here real quick. So Japanese bookbinding is something that I've done on and off for a while. Or it's a different style of bookbinding because I'm really a fan of making. I just really love stationery in general. So I love a nice journal, a nice book of some sort to write in, to draw in. And sometimes you have books that are kind of like messed up, like this this Windows 98 manual here was in very rough shape, and the pages were ripped out and everything. So I had de-spined it and bound it in the style of Japanese book binding or stab binding. But yeah, it reads the same as a regular book, but it's just nice to have. So one second while I grab my stuff. So if you're going to be doing binding like this, we notice here that there are 4 holes, right? So stab binding is like characterized by having, you know, even amount of holes like this and string that holds it all together. You know, it's all tied together. There's no glue used. There's nothing too fancy. It's just a very, very bare bones way to make, you know, a book. It's easy to add new things to the book if you want to. You can untie it because it's not, you know, it's just regular binding. It's similar to like a binder. It's a bit more long term than that. But what's cool about it is you can do things like have mixed pages. So if you wanted to have, say, you know, a bunch of Windows or Windows 98, you know, materials, and then have a bunch of notes, you could find some, you know, note paper in there. You know, every page could be different. You can make a zine out of it or a scrapbook, which I forget who had done the scrapbook talk, but that was awesome. I watched it earlier. It's also a really quick way to repair something if you want to keep things bound together, but the books are destroyed or they're messed up in some way. You know, it is, you know, easy to learn, but it's difficult to master and make it right. But you can make really nice looking books right off the gate if you go through it. It can be a bit time consuming, more so than just stapling things together, but it looks nice and it's much easier to fix up. So I'm just gonna start off real quick. So I'll have a sheet of paper here. I'll just show how I go through this process here. So let me get this out of the way. So I have this little cutter here. You can use anything you want to, but we know that a normal sheet of American printer paper is going to be 8.5 by 11. So if we're going to be cutting up some paper, let's say we're going to make a small little booklet like one of these, a very small little journal here. We want to make it so that it's, oops, that's not opening. You know, we can cut this into like fourths. So that would be like 5, you know, 11 divided by 2 is 4, or 5.5. And then 8.5 divided by 2 is 4.25. So we can line up all these in this little cutter here. Oops. Now we have 4 pages here. So now I have this really cool tool that broke last night when I was trying to prepare some things for this talk. It normally looks kind of like this, and you can hole punch with it, but it exploded into a million pieces, and I could not get it to work. So I'm going to be trying to do a little bit with this just to show you, but I do have some stuff already prepared. So it's really important when you have a new piece of paper to establish one paper as like your guide paper. And so if you start off here, we know that this is 4 inches or 4.25 inches. You can round it up a little bit to maybe, you know, 5 or whatever you want to. But what you want to do is cut holes into it so that it looks like this. So I have this front paper here, and I have 4 holes that are cut into it that are evenly spaced. This one here is a bit longer. If you get over 3 inches from the top, you might want to have holes on the top and the bottom that are a little bit closer to there and then space it out normally, just because this has to kind of hold into place. And it could be harder if you have a really long piece of paper and you're trying to hold together with just this little loop of string. So I had cut up this one here, and I just punched holes into it. So when I'm going through and I'm trying to add new pages, you can just take some of these, you can pick a binder clip, and then once you have them all lined up the way that you want to, you can just sort of do that and have them held together. Now, for the punching aspect of it, I have this little hole puncher, which you see here. It's like a piece of, or it's like a little ring here, like a sharp ring. You can use like pretty much anything that you want to, as long as you can fit a, you know, about 3 widths of twine through. So let's say we're using this twine here. I'm able to fit like at least 3 of them through, or I could double it up like this. But yeah, that would be about the size of the hole that you want, because you're going to be wrapping things around through them. And so you can use like people use bookbinding awls, which are like basically like picks. You don't have to use that. If you have like even an X-Acto knife, you can do the same thing as long as you make evenly sized holes and they're consistent throughout. So what I normally do for this sort of thing is I'll just like once I have my guide holes punched, I'll just use a puncher like this, which normally I use that thing and it's a lot easier. But this is just sort of my guide. But now once that I've had them all lined up, I can just punch right through all the way to the end. Yeah, this is not happening with these. I'm gonna have to find a new way to do this. Hopefully I can make one sheet at least of these. So taking this out, let me see that, well, since I kind of messed up here, I got one sheet out of it. So I basically made a whole new sheet, out of this. You can use like a book. There's like they have those like hole punchers for binders too, like you used to use in like school. Some people have those lying around the house. I used to have one. I don't know where it went, but you can make something like this. Just punch through. I'll get these out of the way. Just like a cooking show, I have some prepared pieces here. So I had cut up a bunch of types of pieces of paper. So I have these. I have some graph paper. I'm a huge fan of nice graph paper. So I have all these things lined up here, and I'm gonna go through and do the binding process now. So when you do the actual binding, you're gonna want the string to be about 3 times the size of the width or the length of the book. Just to give you a bit of slack, because you can't really put string back once you've thrown it down. So that seems just about right. So I'm gonna put this here. And to actually do the binding part, I use a needle, but depending on the type of twine that you have, you might actually want something a bit bigger. Another option too, instead of threading through a needle, is you can tape it to a needle, although you have to make sure the tape is not so, not so thick on the page, or not so thick on the needle itself to fit through the holes. So there's a ton of guides for this online. You can definitely look them up for stab binding, but I'll show you a very basic technique for it. So I usually start around on the back side here on the second hole. You wrap it around. And so the first one is really important to make sure that you have a good amount of length of string down the end, so that you can tie it after. And so that should be a good amount there for this size paper. So I have these two in this first binding. Hold it with my fingers here. And then I'm going to go through the first hole. I'm going to wrap it around there. All right, so now at this point you can tighten and make a bit more adjustments to it. Oops. All right, so now we have the first real knot, or the first real like bound piece in here. And we're going to wrap this around the front or the top of the book and push it right back through hole number 1. I hope you guys can see this okay too. All right, so now we are currently on the back side. Pull this through. So now we're going to complete this loop on the back, and we're going to go through stage number 2 again, and then go through number 3, and wrap this around too. And it's good to make adjustments along the way too as you're threading these together, because we have that first one that started off here. Just make sure you pull all the little pieces, just to have them tight and snug. You don't have to make them, insanely snug, but snug enough where they're not going to feel loose as you hold them. So, second. Well, actually, one second. I actually missed up a step here. Hold on. Live demos, huh? Be careful not to stab yourself. If you have a thimble, which I should have had, it's definitely more useful. So we're actually supposed to go through number 4 here. It's before number 3. But we do the same techniques of wrapping it around. Oops. Wrapping it around the spine. And so now we're going to do the same thing we did at the top and wrap around the bottom with the 4th hole. Looks like I actually cut a little bit too less of string, which you can also fix too. But so now we're at number 3. Pull this through. And so I did cut a little bit too little of string. This is definitely something that happens. Do at least 3 times the amount, even if you think it's too much. But so a thing that I like to do, which I'll just for the sake of time, not do it, but I like to pull the strings through here, through the middle of the page, and you basically pull the string through the 2nd hole so that it looks seamless through the inside of this part. So you would put this first string in those middle pages, and then you thread this to the same page, pull it down, and wrap it around the bottom, and then knot it up like that. But for here, we can just tie it like this. Don't have to be too crazy. And just tie it up in a knot. And then, well, very, very sloppy right there, but that would be your typical book. I didn't wrap it around number 3 as well either here. I'm running out of string, but that is, I guess, how you turn it into something like this. So yeah, cool. 15 minutes total, okay. So, all right, that should be it for the time. Yeah, I wasn't sure how much time I actually left.
You have another 10 minutes if you want to do Q&A or something like that. I know that a lot of people are asking what the hole punch tool that you were using was.
Okay. All right, let me take a look at this stuff here. My goodness. Alrighty. So this hole puncher here that I'm using, this is a thing I got at Michael's, right? So this normally has this little thing in here that has a spring that this is wrapped around, or you put this in here. But something broke, and I don't know if like a little piece flew somewhere or something. But I had thrown this in there, and I had taken like a screwdriver, hammers it into place.
This is how you troubleshoot live demos when it's crafts instead of computers.
Yes, but so what it's supposed to do is like go down, hold it so it doesn't destroy it, but it makes a hole. That's like a really nice hole. It's much easier to use, but it keeps exploding on me, and so I'm definitely gonna have to fix it. I think that it looks like there's a crack that happened, which I don't know if you can see in the light, but there's a crack that messed up the pressure that holds this thing in place. So, but yeah, I mean that's a really cool thing that I have. I bought when I was doing this a lot more. But you can use any kind of hole punch. You can use a needle. You can use an X-Acto knife if you want to just cut out holes in specific ways. But as long as you can make a first good base hole for something, you can do whatever you want with it. Cut around it and stuff. So yeah, you can use a tapestry needle for knitting too. Anything that you have that's really it's really sharp and able to pierce through pages. And this printer paper, this is like 28 weight printer paper. It's very thick. This is actually a lot thinner. If you have very thin paper and you want to bind, that's an advantage to using that. Anybody have any questions? Any more questions?
We did have somebody who popped up in the Q&A that said the tool is called a Japanese screw punch and included an Amazon link. So thank you for that.
Oh, sweet. That's awesome.
Somebody wanted your ZSH theme. Is that available in your notes?
Wait, say that again?
Somebody wanted your ZSH theme from earlier.
Oh yeah, I can throw that in there. This is just a bash like from my bash RC. So I'll just throw this in here. It's just a PS1 line. But yeah, I definitely want to get more into this aspect of it. Since I ended my our podcast, the Floodguard podcast, I'm gonna have a lot more time to teach classes. So I definitely want to go through and do some firmware analysis streams, and I'll give all of my themes and all of my CSS to whoever wants it. But yeah, definitely follow. You can follow up with me on Twitter at netspooky. DM me if you have any other questions about this stuff. I did a very, very high level overview of everything. So yeah.
Well, thank you so much for both sides of that interesting content. I hope that everybody does check out the website, and I'm going to be trying out that book binding for sure.
Awesome.
Next up, we have Caitlin Bowden, who is going to talk to us about image-based abuse and also has a makeup tutorial for us.